Alright, Advanced Math, last mini lesson on area today. And we're going to just find the area of complex figures today. That means just sort of, figures maybe we don't have a name for or that take a little extra work to find their area of. So go ahead and write this down as your next title. And when you're all set, mark your page, close your notebook, listen and concentrate. Alright, so let me give you a little reminder. So yesterday we talked about trapezoids, right? And we did some trapezoid volume. And trapezoids there was no formula for. We just had to find them. We had to kind of cut it into 2 or 3 different figures. Then we just had to find the area of this, and find the area of this, and find the area of this, and add them all together to get the total area. And that's what we're going to do today. We're going to look at some figures that are not really, don't have a formula, don't even necessarily have an easy name to give sometimes, and just see how those go. So here we go. Let's go here. So Jamie's planning to cover a wall with red wallpaper. That's a common area question. We're going to kind of cover something. So wallpaper, that would be like covering the inside, right? So that's an area kind of question. The dimensions of the wall are shown below. How many square feet of wallpaper are required to cover the wall? So when I look at this, I've got some work to do to kind of figure out what shapes I have here. So this, just to give this a name, this is a 1, 2, 3, 4, 5-sided polygon. So this is a pentagon. And it is an irregular pentagon. Irregular means not all sides the same. A regular pentagon usually looks like this, kind of. Like 5 of the same side, if I had drawn it just right. Kind of the classic pentagon look. This is an irregular pentagon because their sides are not all the same length. But that's beside the point. So let's find the area. So to find the area of this, what I want to do on a compound complex figure is I want to partition into things that I know how to find the area of easily. Triangles, rectangles, and parallelograms. All those have formulas, and so it would be nice to be able to partition into those. So this one's not too tough. I can partition this one here. And then I've got a triangle and a rectangle. So there's just 2 parts. So that's kind of nice. I can find the area of each and then add them together. So let's start with the rectangle's easy. So the rectangle, the area of the rectangle is base times height. So my base is here is 8 feet. My height here is also 8 feet. Looks like I actually have a square. And so my total area is 64 square feet. Here, so 64 square feet. For the square, for the rectangle. And the triangle, let's see, so I've got, the base is easy to tell, the base is here, that matches here, so my base is 8, and my height I may have to figure out, so this is 8 feet, this whole height of the whole wall is 10 feet, so that must mean this height of my triangle from bottom to top is 2 feet. So remember, triangles, their formula is base times height divided by 2, or 1/2 times base times height, either way. So that's going to have a base of 8, a height of 2, that's 16, and do not forget to multiply by 1/2 or divide by 2, easy to do. Divide by 2 is going to give me 8 square feet. So this has an area of 8 square feet. And so for the whole figure, then has an area of 64 for this, 8 for this, so she'll need a total of 72 square feet of wallpaper. All right, not too bad. Let's do another. Well, let's do one together. All right, here. So open your math notebook. Take a sec to draw this figure, and we'll talk it through. So let's find the area of this guy. All right, so what I want to do, this is called a compound figure or a complex figure. Compound figure. So my plan is going to be to partition into triangles, rectangles, and parallelograms. And the reason for that is I have a formula for all three of those. So it makes sense to try to cut it into pieces where I know a formula. So this one, depending on how you want to look at it, you can do this in a couple of different ways. If you want to cut horizontally, you could partition this into 3 rectangles like that. 1, 2, 3. You could also probably partition it like this. And then you'd have 4 rectangles, 1, 2, 3, 4 to add together. Either way is fine. I'm probably going to choose 3 over 4 just because it seems easier. And there's probably other ways you could do it too. I guess you could do this. You could do 1 this way and 1 this way. Doesn't make any difference how you choose to partition it. I think I'll do that. So now I've got 3 rectangles. And all 3, I need to know the base and the height. Some of them are going to be easier than others to find the base and the height of. So this one here, rectangle, the base is 21, and the height is 13. That's an easy one. And that is 273 cubic units. There's no measurement on here, so I'm just going to say, or square units rather. So just do U squared, square units. This one looks pretty easy. Base times height. The base is 4. The height is 3. So that's 12 square units. And the one that's going to take a little work is this one. I got to figure out what its base is. And I've got to figure out what its height is. Neither one of those are given to me. So that's going to take a little bit of work. And that's the trick on these, is sometimes you have to use some logic to figure out the base and height. So to find this, here's where I'm going to look. I see that this is 10 all the way across, and this part of it is 4. So if this is 10 and this is 4, then this has to be the other 6, right? 6 plus 4 makes 10. This matches this. So that's the same as this. So that's how I'm going to figure out that right here my base is 6. And that took a little bit of reasoning and logic. So my base is 6. Height. Let's see if we can figure out the height here. I don't see. 3, 13. Where is this? I don't know if I have enough information. Do I have enough information to find this piece here is what I need? I don't have this. I don't have the whole height either. I thought what I expected to see here is I expected to know the whole height here, and if I'm just missing it, let me know. So I know this is 13, this is 3, so I was expecting to use those to figure out the other part from knowing the whole height, but I don't. So I'm just going to have to make up what it is. Well, I was going to try to reason my way through and say, well, if I know this is, say, 20 all the way, and this whole thing was 20, then I would take away 13, take away 3, and make that be 4. But I'm not giving this. I'm just going to have to give you that. I'm going to say that is 4, let's say. So if my base is 6, my height is this 4 plus this 3. So base is 6 times 7, and that is 42 square units. So now I've got 3 areas to add together. I've got my 273 plus my 42 plus my 12. And that adds up to 327. All right. And so that's what you do. You just partition it into triangles, rectangles, and parallelograms, and then apply your formulas to each one. Since this went a little wrong, let me make sure I emphasize to you, you do not get to just make these numbers up most of the time. This one, unless I'm just missing it, just did not give me enough information to figure this out, so I had to give it to you. But normally you have to use, say, this side and this side to figure out this side, just like we did here. Like I didn't make up that 6. I figured it out from the 10 and the 4. And so I don't want to give you the wrong impression that you just get to make up numbers or say, it looks like maybe 3. You do have to figure them out from the pieces you're given. All right, so that is how you find the area of a compound figure. If you need to go back and watch either example again to feel good about this before class, please do. But once you feel good about it and once you have your notes done, you're all set. See you tomorrow.